Hello everyone, welcome to me, Learning Rust. Today I'll continue the 8th chapter, we talk about collections, and we'll continue. We talked about strings, talked about vectors, and now we're going to talk about hash maps. So let me just go into chapter 8 here. Okay, great. Okay, the last of our common collections is the hash map. The type hash map KV stores a mapping of keys of type K to values of type V using a hashing function, which determines how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different name, such as hash, map, object, hash table, dictionary, or associative array. Just to name a few. Hash maps are useful when you want to look up data, not by using an index as you can with vectors, but by using a key that can be of any type. For example, in a game, you could keep track of each team's score in a hash map in which each key is a team's name and the values are each team's score. Given a team name, you can retrieve its score. We'll go over the basic KPI of hash maps in this section, but many more guidelines are hiding in the functions defined in the hashmap KV by the standard library. As always, check the standard library documentation for more information. Okay, creating new hash map. One way to create an empty hash map is using new and adding elements with insert. In listing 820, we keep track of these scores of two teams whose names are blue and yellow. The blue team starts with 10 points and the yellow team starts with 50. So let's see what we're doing here. Okay, we'll use standard collections, right? Hash map. Okay. Okay. All right. I'm always making this mistake. I need double colon here. Okay. So now we define immutable, immutable scores hash map, and I think we need to say, we don't even say what type it is. It will deduce it from the usage. So currently it'll be unknown type, right? Yeah, unknown and unknown. Okay, now I want to insert things, so I'm doing scores. Insert string from blue. It's 10. And if we go here and insert string from yellow, it's 50. So now the type is string I32. Let's see what if I'm doing something like this. Here I'll do red team with 20. Okay, so the type here becomes a slice, like a string slice, and the inserts in line 7 and 8 are no longer valid. Okay, so let's revert, and now it's a string object that we have here. Note that we need to first use the hash map from the collection portion of the standard library of our three common collections. This one is the least often used, so it's not included in the features brought into scope automatically in the prelude. Hash map also have less support from the standard library. There is no built-in macro to constructing them, for example. Just like vectors, hash maps store their data on a heap. This hash map has keys of type string and values of type I32. Like vectors, hash maps are homogeneous. All the keys must have the same types as each other, and all the values must have the same type. Yeah, as we saw, we can use either string or the slice, but we can use both. Okay, I wonder if we can control the hash functions, like the hashing function itself. Let's move on. Assigning values in a hash map. We can get a value, accessing values in a hash map. We can get a value out of a hash map by providing its key to get method as shown in listing 821. So after we have this, can go and let team name equals string from blue, right? And then let score equals scores dot get, and I'm getting team name. Let's see, it's an option in case it's not there, and then copied, which we don't know yet, but I assume it copies the value, and then another thing we don't know called unwrap or. Like if I'm doing just copied, it's still an option, and if I'm doing unwrap, unwrap or default. Okay, so before I'm reading, team name. Okay, I need a reference here. Okay, so before I'm reading, I have the team name here, which is a string, and I have a score. I'm getting the value. It's an option because you can't know in advance if a hash map will contain a specific key value pair. I copy it. I assume that it just copies the memory, because if I take this, if I'm not using copy, I'll check this. It means that probably the value here will no longer be valid. We'll check this out, and then unwrap or probably transfers. Like this one is an option, right? It's an option, and unwrap or probably gets me the value that's in the option, and if the value is a none, if like the enum there is a none, that it returns the default value, which is 0. Now let's play a little bit before I read on. Try to understand. If I remove the mutable, this will be error, right? Okay. Okay, now let's see. Another thing I wanted to see if I can use a literal here. I'm using blue here. Is it legal? Yeah, it's legal. And also this, probably legal. No, it's not legal. Straight bound string borrow is not satisfied. Okay, I cannot borrow a literal. Okay, but I can use this. I don't have to have a string here. Okay, good to know. Okay, let's go back to this. Okay, now copied. If I remove the copied, I expect it to be an error. It's default. Here is the error. Expected I32. If I'm using unwrap or here, so the copied is not what I thought it would be. What copied does, it... Okay, we'll read up on it. Maps and like the help says it maps an option T to an option like from a reference to a non-reference by copying the contents of the option. Okay, basically when I'm getting a get, I'm getting an option with a reference to the value. That's why this is how they keep this value being valid and not borrowed. So it returns an option with a reference. So if I want the option without a reference, if I want to get like a value here, then I need to make it copied, which transform it from an option of a reference to an option of a value, of a borrowed value, and then I can unwrap this value, take ownership of it, or return the default value. Okay, I think I understand it. Let's read on. Here, score will have the value that's associated with the blue team, and the result will be 10. The get method returns an option reference v. If there is no value for that key in the trash map, get will return none. This program handles the option by calling copied to get an option I32 rather than an option reference to I32. Then unwrap or to set score to 0 if scores doesn't have an entry for the key. Okay, basically less than I figured out, but okay. We can iterate over each key value pair in a hash map in a similar manner as we do with vectors using a for loop. So the for loop is, delete this, for, now we have key value and a reference to scores. And then I can print line with a and a v here. Let's just even run it. Cargo run. And we have blue 10 and yellow 50. Great. Okay. Let's move on. Hash maps and ownership. Okay, I think now they're going to explain about this thing. For types that implement the copy trait, like I32, the values are copied into the hash map. For owned values like string, the values will be moved and the hash map will be the owner of those values, as demonstrated by listing 822. So what we have is a field name. So yeah, if I'm doing something like this, I'll try not reading forward. Just it's string from blue. If I'm defining something here, and then I put it here, now it should be still okay, right? Should be okay, but the key that we have here is borrowed. So if I want to print it afterwards, I want to print it like this, it will be an error because it is borrowed. Yep. Okay, so now if I'm doing this, this will be okay, and this is not okay. Great. We weren't able to use, like, this is what we're doing here probably, field value, field name, field value, then we put it into the hash, and after that we cannot use it. Okay, yeah, that's what we tested. We weren't able to use the variables field name and field value, but here in our case it's the variable key. And after we've been moved into the hash map with the call to insert. If we insert references to values into the hash map, the values won't be moved into the hash map. The values that the reference point to must be valid for at least as long as the hash map is valid. We'll talk more about these issues in the validating references with lifetimes section in chapter 10. So I guess if we try to put something now with a reference, it will be an error with, that says they have to define a lifetime, which we haven't looked into it. Well, in chapter 10 we'll learn about this. But let's just get this error, make it into a string. String from, let's have a string of 10 instead. Yeah, so delete this, and we have a value here. Okay, and now if you want to print the value, not the key, it'll be an error. But if you want to be like smart and just pass the reference, I think there's no error. I can pass a reference, and I don't have to think about lifetimes here. Let's see if I can think of somehow to make it require a lifetime or something. Nope. Okay. So I guess we'll see about lifetimes in the future. How we can make sure that this hash map, that this value, maybe if I'm doing something like this, this will be an error. But I cannot do this because it's a different scope. So I have no idea about lifetimes. I guess we'll learn about this in the future. Okay. Updating a hash map. Although the number of keys and values, key and value pairs is growable, each unique key can only have one value associated with it at a time, but not vice versa. For example, both the blue team and the yellow team could have 10 stored in the scores hash map. When you want to change the data in a hash map, you have to decide how to handle this, the case when a key already has a value assigned. You could replace the old value with the new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value, or you could combine the old value and the new value. Let's look at how to do each of these. Okay, overriding a value. So, and let's get rid of this. And so I have here blue and 10, right? And then I want to insert blue 25, right? It's just insert. Okay, and let's print the scores in this fashion. Print line. Scores. Okay, let's see. Let's run it, and we have blue 25. So we put 10 and then put 25, and it overrides the value. Okay. It's common to check whenever a particular key already exists in the hash map with the value, then take the following actions. If the key does not exist in the hash map, the existing value should remain the way it is. If the key doesn't exist, insert it and the value for it. Hash maps have a special API for this called entry that takes the key you want to check as a parameter. The return value of the entry method is an enum called entry that represents a value that might or might not exist. Let's say we want to check wherever the key for yellow team has a value associated with it. If it doesn't, we want to insert a value of 50, and the same for the blue team using the entry API. Let's look at the code. Okay, so we have the scores, we have the blue team, and now I want to scores entry here. Scores entry, and I pass a key to entry, which is string from yellow, and then what I'm getting here after this is probably something of type entry, and something of type entry I can do or insert, and or insert 50. Right, something is wrong here. Because I need to do string from blue here. Great. So now I have this insert, and if I want to insert a blue here, okay, so now I'll have 50 and 10. Yeah, this is what I'm expecting to have. Yeah, blue is still 10 and yellow is 50, because here the entry is empty, so I can insert it, and here the entry has something, so or insert will not insert. Okay, so the or insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists. If not, inserts the parameter as the new value for the key and returns a mutable reference to the new value. This technique is much cleaner than writing the logic ourselves, and in addition plays more nicely with the borrow checker. Okay, so basically I can even, I'm doing this, I can even get a reference to this value or to the value that's inside here. Yeah, because basically the value here, it's 10 and not 50, because I already have this value. Let's just double check that. Let's see that we're printing 10 and then this. Because okay, because it's borrowed, I can't use it here. This is weird. Yeah, let's see what's there. Cannot borrow scores as immutable because it is also borrowed as mutable. Immutable borrow occurs here, right? And immutable borrow occurs here. Okay, so this borrows a mutable. It's mutable. Okay, so how can I force it not to be mutable value? So if I put here just a reference to I32. Can I make it? No. Okay, this is interesting. So I cannot, if I extract this, then I can't use it as an immutable anymore. That's interesting. And if I'm doing this, like this, and then I'm doing here, let val equals scores get string from, I don't have to use this, I can use this, blue, right? This would be an option. Okay, assumption. And I'm using copied, right? And then unwrap or 0. And then the value is an I32. So basically with this, I'm removing the reference. So now the score is no longer mutably borrowed. So now we need to remember that every time I want to access something from a hash map and then still use the hash map, I'll need to copy the data or do something else that makes the data that the mutable borrow that I did from the hash map will be invalidated, so I can use the hash map as an immutable object again. I hope it makes sense. I will not remember this, but luckily we have our compiler errors to help us with this. Yeah, I could figure out from this error, let me just make the error more visible. I could figure out from this error what I need to do. Okay, updating a value based on the old value. Okay, another common use case for hash maps is to look up a key's value and then update it based on the old value. For instance, listing 825 shows code that counts how many times each word appears in some text. We use a hash map with words as keys and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, we'll first insert the value 0. Okay, let's see. Let's copy it and then we go over it. We don't need to use. So we have this text, and then we have a hash map, and then I'm going over the words. This probably splits this string into words, and then I'm looking at a word, I'm entering a word or inserting a 0, and then I'm getting a mutable value to count, and then I'm adding 1. Okay, so basically it's just one step after what we did back then, that the insert returns a mutable reference to the value that we have inside the hash map. Okay, the code will print hello 2, world 2, hello 1, wonderful 1. Let's just verify hello 1, world 2, wonderful 1. Oh, it's a different order. You might see the same keys value pairs printed in different order. Recall from the accessing values in a hash map section that iterating over a hash map happens in an arbitrary order. The split whitespace method returns an iterator over subslices separated by whitespace of the value text. The or insert method returns a mutable reference to v to the value for the specified key. Here we store that mutable reference in the count variable. Notice this is a mutable reference. So in order to assign to that value, we must first dereference count using the asterisk. The mutable reference goes out of scope at the end of the for loop. So all of these changes are safe and allowed by the borrowing rules. So yeah, so because this mutable reference goes out, I can print this. If I would have done it outside of the reference, I would not be able to do this. So let's go back, actually. Let's go back to this. Oh, I had thing that was not working, right? I had this. So if I'm doing this, right, I can no longer print it. But what happens if I'm doing something like this? Okay, this is still wrong. This is okay because I'm not printing the value. But if I'm doing print line value, is this okay? This is okay, yeah, because after I'm finished, I'm not using the value anymore, and it can be removed from the scope. Yeah, if I'm using this, it'll be wrong. Oh, sorry, entirely wrong, but this is wrong. Okay. Excellent. By default, HashMap uses a hashing function called SIPHash that can provide resistance to denial of service attacks involving hash tables. This is not the fastest hashing algorithm available, but the trade-off for better security that comes with the drop-in performance is worth it. If you profile your code and find that the default hash function is too slow for your purposes, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. We'll talk about traits and how to implement them in Chapter 10. You don't necessarily have to implement your own hasher from scratch. Crates.io has libraries shared by other Rust users that provide hashers by implementing many common hashing algorithms. Yeah, so basically, yeah, default hash maps are not very good. It's a good thing when you use hash maps for something that's pivotal, to actually profile the map, see that that all the keys are spread evenly inside the bins. If it's not the case, this could lead to very serious performance issues, because all the concept of a hash map is built on the of getting a very close to one-to-one transformation between the hash of the key to the slot in the array that the values are stored in. Okay, so summary. Vectors, strings, and hash maps will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Okay, we'll go over the exercises, and next time I will do these exercises. Given a list of integers, use a vector and return the median. When sorted, the value in the middle position, and mode, the value that occurs most often. A hash map will be helpful here of the list. Yeah. So one thing is to get a list of integers and then get the median and the mode. The other thing is convert a string to Pig Latin. The first consonant of each word is of each word is moved to the end of the word, and a is added. So first become erst fei. Words that start with a vowel have hey added to the end. Instead, apple becomes apple hey. Keep in mind the details about UTF-8 encoding. This will be interesting. Using a hash map and vectors, create a text interface to allow a user to add employee names to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let the user retrieve a list of all people in the department or all people in the company by department, stored alphabetically. Okay, this is interesting. This is like everything together. We have strings, we have hash maps, we have vectors. Interesting. The standard library API documentation describes method that vector strings and hash maps have that will be helpful for these exercises. We're getting into more complex programs and which operation can fail, so it's a perfect time to discuss error handling. We'll do that next. Okay, so this is it for now. Next time we're going to do these 3 exercises. I will be using some API documentation or this book. I think we'll start with this book, and then I'll have the documentation ready, or even I may use it from here. Thank you very much. See you next time.